All right, thank you for joining us today. And in this video, we are going to apply the idea of what change rule, right? But before I start the change rule, I want to help you with the idea of change rule with two methods, and then from there we can go through the process and then we are done, right? So the change rule, good. So this is the change rule, and the change rule is like if I have y, which is equal to let me say gen of x to the power n, right? Here we are saying that the one in the bracket here is a function of what? Another function, right? So we need to apply the idea of change rule to solve this. So I'll go through the long process of getting the formula for the change rule. Then I'll show you the shortcut of doing this, right? Then when I finish, I'll show you the other one too before we go through the examples. So now let's see how we are going to go through this. So the first thing I'm going to do is I'm going to let u to be equal to gen of x, the one in the parentheses. It means that my new y, my y now is going to be u to the power n, because this gen of x here is the same as u, so u to the power n here. That's what we are going to get. So now we need u prime, right? So now we can see that this u here depend on a function of x, right? So we are going to differentiate u with respect to what? X. So du over dx will be equal to gen prime of x. That's what you are going to get. Then this our y here also depends on u. So we are going to have dy over du, which is equal to, then we apply the power rule, n down u n minus 1. So that's what you are going to get for that. Now, if we have something like this and we are differentiating, we know that we need to look for dy over dx. So now what is dy over dx? Dy over dx is equal to dy over du times du over dx. So this one will be dy over du times du over what? Dx. The idea is that now I can cancel this and this, and when I multiply back, I will have what is here, the same idea, right? So that is the implication. So now what is dy over du? Dy over du is what is here. So I'm going to have n u n minus 1 times what is du over dx? That is the gen prime. So we are going to have gen prime of x, and then here we know that we have u here, and we know that u is the same as gen of x. So in place of u, I'm going to put gen of x there, which is n minus 1 times gen prime of x. So this is y prime. So y prime is equal to this right here. Good. So that is the formula that we are going to achieve. Now, the shortcuts of not going through this always is, now let's pick the function again. Y was equal to gen of x all to the power n. Then if I want to differentiate this function, it's very simple. What am I going to do? I'm going to use the idea of power rule. Now y prime will be equal to, the power rule says that if I have a function like this and it's to the power n and n is constant, then I can drop the n, maintain the whole function again, which is gen of x to the power n, but I'll subtract 1. But here we are going to do something small to it. After I'm done with the power rule, I'm going to pick what is inside the parentheses, and then differentiate. So what is inside the parentheses is gen of x. So I'm going to differentiate gen of x, and I'm going to have gen prime of x, which this is right here, the one that we have here. Do you get it? So that is the idea with what you were trying to prove. So you can go through by picking variables. So for example, the one that we are coming to do here, we can choose the idea of picking u and then changing our variables through, and when you are done, we get this, or we can just use the idea that we've gotten here straight away, right? Another one that I need to talk about is when I have the function. But what I'm going to talk about mostly, for me, I use it for the trig functions, right? So I have f of x and then I have g of x, right? The reason is, now we have another function which is also in terms of another function. Like this is like composite function, right? So the same idea, I will let u to be equal to g of x, right? Then it means that y will be equal to f of u, right? Because the g of x is equal to u, which is here. So I'm going to replace the g of x by u. Now I need du over what? Dx, because the function here is in terms of what? X. The same thing like what we did. So du over dx will be equal to g prime of x. Then here the function is in terms of u. So I'm going to differentiate y with respect to u, which I'm going to have f prime of u, right? The same idea. So now what is dy over dx? Dy over dx is the same thing, dy over du times du over dx, which we have dy over du here, du over dx also there. So this is going to give us f prime of u times g prime of what? X. But we know that this u here is the same as what? G of x. So we are going to have f prime of g of x times g prime of x. So this is what we are going to get for choosing this particular function, like if it is of this form. So let me just copy this one and come and place it here, or let me put it here, and then take the same function here and show you the shortcut. Y is equal to f of g of x. Now y prime will be equal to, first the derivative will hit what is here, right? Unlike the one with the power rule, that we need to hit the power rule before we go to what is inside. This one, there is no power here. So we need to first, the derivative, we need to hit the one here first, which is f prime. Then I maintain everything in the parentheses. Then now times, now I go inside the parentheses and I see that there is g of x. Then I take that function and what? Differentiate, which is going to give us what we had here. So going through this process, also having the idea of differentiating f prime first, followed by g. Differentiate f followed by g. But when you differentiate f, you should have g of x inside f prime of x times, then I'll differentiate g of x. So this is what we are going to do. Mostly for me, I use this one when I'm dealing with trig functions. For example, if I have y to be equal to sine x squared, then here my f is the sign here, and my g of x, that's how I do it. My g of x is what? X squared. So if I'm using the idea of what we just learned, first the derivative must hit the f. So here first the derivative will hit the sign, which will change it to what? Cos. Then I maintain what is inside the bracket as we saw it here. Then I'll multiply it by, now I'll pick the one in the bracket and differentiate, which is the g of x. So this one will be 2x. So mostly that's what I use for this formula. I use it for trig function, composite function for trig. But we can also use it for this particular function here. When we choose our x and u, we can also do the same thing, and we are going to get it also right. Right. So this is what I wanted to share before we go through the whole process, right? So we have the power rule. This one is when y is equal to g of x or to the power n, right? And then the one that we have here is when we have something like this. So let me use the idea of this to solve this, right? So the first thing is, I want to turn this function to this form, like something to the power, right? So this one can be written as 9 minus x squared all to the power 1 over 2, right? So this is what I'm going to get. If I want to go through the normal like chain rule, then I'm going to let u to be equal to 9 minus x squared, right? So since I'm doing this for the first time, let me go through the process using what we just learned from deriving the formula. Then we come and do it straight away, right? It's advisable for you to do it straight away. So here I'll let u to be equal to 9 minus x squared. So if u is equal to 9 minus x squared, then what will be y? Y will be equal to u to the power 1 over 2, because now what is here is equal to u. So I place the u here and then to the power half. Now u depends on x, so I need to differentiate u with respect to x, which is going to give us, when I differentiate 9, I'll get 0. But when I differentiate minus x squared, I'm going to get minus 2x, right? So that's what I'm going to get. Good. Now I need to also differentiate this function right here. Now this depends on u, so I'm going to differentiate y with respect to u, which is going to give us, using the power rule, we are going to have 1 over 2 u to the power half minus 1, which is going to give us minus 1 over 2. So what will be y prime? When I say y prime, I mean dy over dx. This is going to be dy over du times du over what? Dx. So we multiply this by that, so that this cancel this, and we have dy over dx, which is right here. So when I put the functions in, dy over du is equal to this, du over dx is also equal to this. So I'm going to have 1 over 2 u minus 1 over 2 times minus 2x, right? Now what is u? U is equal to 9 minus x squared. So when I do backward substitution, I'm going to have 1 over 2 9 minus x squared to the power minus 1 over 2 times, let me just clean this one, times minus 2x. So this is what I'm going to get at the end of the day. But we can go through this by doing direct what? Differentiation. Let's look at this. So now if I want to do the direct by using this, the idea of this, then I'm going to have this one to be y prime to be equal to, first I need to apply the power rule. So the power rule says that if I have a function to the power n something, then first I drop the power down, then when I finish I maintain the whole function, which is 9 minus x squared to the power 1 over 2, but I'm going to subtract 1 from the exponent. Then here the change rule also say that when I finish doing the power rule, now I need to look at the function inside the parentheses and differentiate. So I'm going to differentiate what is inside the parentheses. So I'm putting prime here. If I'm putting prime there, it means that I'm taking the one in the parentheses and putting the prime here. You can do it straight and just write minus 2x, which is also right. So I'm going to have 1 over 2 9 minus x squared minus 1 over 2. Then when I differentiate 9, I get 0. But when I differentiate negative x squared, I'm going to have minus 2x, which is the same as what we had here. So going through the whole process is the same as going through the shortcut, the same thing here. Good. So we take more examples and then you understand it better. Let's look at B. Now we learned exponential function, and we said if I have f of x to be equal to e to the power kx, then f prime of x is equal to k drops down and kx, right? So you can see that the k here is the same as the k here, so kk, right? But the idea, how did we do this? Because if you know how we did this, then you'll be able to differentiate all other functions. For this one, we were able to write this in this form because the function here was just a linear function. But this is not a linear function, it's a quadratic function, maybe cubic function, maybe fourth function, right? So what we need to do is we need to learn how we move from this place to this place, not the idea of just dropping what is here down here. So what did we do? We are saying that if I want to differentiate an exponential function, first I'll maintain the function, then I'll multiply the function by the derivative of the top. So I need to differentiate what is here. So when I differentiate what is on the top, I will just have k. Because when I differentiate kx with respect to x, I'll get what? X. And this is going to give us k e to the power what? X. So that is the reason why we had, when we differentiate this, you will see that the k here drops down. So it means that if the function is not a linear function, then we cannot just drop the coefficient of x down there, but we need to have the idea of, we need to differentiate the what? The top. So now let's see what we are going to get when we differentiate this. Okay, so f prime of x will be equal to, I will maintain the function times, then I will differentiate the exponent. What is the exponent here? The exponent here is 4 minus x squared. That's the power, right? So I'm going to differentiate 4 minus x squared prime. So when I put prime here, meaning that I'm differentiating that. So I maintain the function, then I picked what is on the top here, and then I'm come to differentiate. So that is how you can, differentiate any other exponential function when the base is e and you are just differentiating. So this is going to be e to the power 4 minus x squared times, when I differentiate 4, I'll get 0. But when I differentiate minus x squared, I'm going to have minus 2x. So this one can be simplified to minus 2x e to the power 4 minus x squared, which is very nice from this side. Right. Now let's look at C. Good. So C of this form. Now let's use this idea right here, right? So if I want to do this, then what will be g prime of x? Now let's first apply the power rule. 8 drops down. Then I maintain the whole function. But I'm going to subtract 1 because of the power rule. Then I'm going to multiply this one by the one in the parenthesis, the derivative. So I multiply this one by x to the power 3 plus 2x plus 1 prime. You can just do the differentiation straight, but I just want to put this one so that you will see what I'm differentiating here. So what did I do? I dropped the 8. I maintained the whole function, but I subtracted just minus 1 here. Then when I finish, I'll pick the one in the parenthesis and differentiate. So when I simplify this, I'm going to have 8 x to the power 3, 2x plus 1 to the power 7 times. Now when I differentiate x to the power 3, I'm going to have 3x squared plus, when I differentiate 2x, I'm going to have 2. When I differentiate 1, I get 0. So this will be the final result for this. You don't want to expand this. The only thing maybe you can do here is just, you can bring this one in front and have something like 8 3x squared plus 2, then x to the power 3 plus 2x plus 1, 7. And the only thing I can also do is I can multiply the 8 by this and the 8 by this. But I can also leave the results here. Let's look at D. I have this function here, right? But I look at the function and then I see that we have two functions combined. We have 2x minus 5 to the power 3, and we have 3x plus 7 to the power 4. So since we have two functions that are multiplying, then which rule are we going to use? Which rule are we going to use? So the rule that we are going to use here is the product rule. And we've learned the product rule. We said if I have two functions that are multiplying, then I'm going to choose the first function to be A, and then maybe the second function to be what? B. So A is equal to 2x minus 5 to the power 3, and B is equal to 3x plus 7 to the power 4. Then what is the product rule? The product rule says that if I want to differentiate a function, let's say y prime, then it should be a prime b plus b prime a, right? So it means that I need to now differentiate this and also differentiate that. So when I want to differentiate A, that is when I need to use the change rule. So first I saw that I need to use the product rule. When I got my A and B, then I saw that okay, I need A prime and B prime. But for me to get my A prime, I need to use the change rule. So let's use the change rule. 3 drops down. I maintain the whole function to the power 3, subtract 1 times, then I differentiate what is inside the parentheses, prime. I put it there so that you know how I did it. So 3 drops down. I maintain the whole function, but I'm going to subtract minus 1 from the top times I pick what is inside the parentheses and differentiate. So when I simplify this, I'm going to have 3 2x minus 5 squared. Then when I differentiate this, I'm going to have times 2. When I simplify this, I'm going to have 2 times 3 is 6. So 2x minus 5 to the power 2. So this is what I'm going to get. Now let's look at B prime. So B prime 2, we need to definitely use the idea of change rule again. So B prime will be equal to, use the power rule first, 4 drops down. Then I maintain the whole function, which is 3x plus 7 to the power 4, but I'm going to subtract minus 1. Then I pick the 1 in the parentheses and then differentiate. So 3x plus 7 prime, right? So 3x plus 7 to the power 3. Then when I differentiate this, what am I going to get? 3. Then when I simplify, I'm going to have 12, 3x plus 7, 3. So you see that if you become very good, you can just tell that, like you can just look at the equation and write y prime. For me like this, I can just do the product rule and the change rule at the same time. Like I just look at this function, then I write that y prime is going to be 2x plus minus 5 to the power 3 times 4. I can do it straight away. But if you cannot do it straight away, what you can do is pick your A, pick your B, find A prime, find B prime, then do cross multiplication. This time is this, and this time is that. That's all. So this one here will multiply this one here, and then this one here will multiply your final simplification here by adding. So, or if you record the formula to write it this way, then when we finish, you look for what is A prime. A prime is here times B, which is here, which is like this times that. So we are going to have 6 2x minus 5 squared times the B, which is 3x plus 7 to the power 4th, right? Plus what is B prime? B prime is here, which is 12x to the x3 plus 3x plus 7 to the power 3 times A. A is here, which is going to be 2x minus 5 to the power 3. Good. So this is what you are going to get. I don't need to simplify it again. This is what I'm going to get at the end of using the product rule. So somebody can just look at the function and just write this, which is going to be what? Right. But if I were you and then I'm now mastering product rule and this, I pick my A, I pick my B, A prime, B prime, I go through the process, multiply this by B prime, multiply this by A prime. When I become good, then I will think of going straight, because when you are going straight you might make a mistake when you are doing it. So now let's look at the next question. The next question here, we want to find the equation of the tangent to f at a given value of x, right? So we want to find the equation of the tangent. So the first thing is, what is the equation of the tangent? The equation of the tangent is y minus y1, which is equal to the slope x minus what? X1, right? But don't forget, my y1 here is actually the same as f of x, right? And then my m here is f prime of x, right? So I can even rewrite this one as y minus f of x which is equal to f prime of x, then x minus x1. But now I'm going to do something. You see, if I put here to be x and here to be x, we have x here. So you might think this s is the same as this s, the same as this s, but no. So what I'm going to do here, this one should be x1. So y1 goes with x1. Good. And this one too here will be x1. So I'm going to have x1, x1. So that this x1 goes with this x1 goes with this x1. So what is x1? X1 is the one given here, right? So when you see x is equal to 1, that is your x1, right? But when I take the derivative and I'm doing it, I put this one too also inside. So I'm going to equate this to be to x1. So don't forget that is your what? X1, right? Good. So now since I know x1, I can write this one as y minus f of 1, which is equal to f prime of 1, then x minus 1, because this is x1, 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 right? So now I need to look for f of 1 and then f prime of 1. I have f of x to be this, so I can use that one to find f of 1. So x squared plus 4 e to the power 1 minus x to the power 3. So what is f of 1? 1 squared plus 4 e to the power 1 minus this. Then this will be 1 plus 4 e to the power 1 minus 1. 1 plus 4 e to the power 0. E to the power 0 is what? 1. So I'm going to have 1 plus 4 times 1. And this one will be 1 plus 4, which is equal to 5. Right. So now I have f of 1 to be 5, which is equal to. So the only thing that I need here is the slope, right? And then the slope is like I need to differentiate the function and plug in 1, and then I'm done, right? So that's what I need now. So I'm going to now find f prime of x. What are you going to get when you differentiate the function? So when I differentiate x squared, what am I going to get? 2x plus. Now I have a constant multiplying an exponential function, so I can maintain my constant here. And we just learned how to differentiate an exponential function. We said maintain the function times, then you differentiate the top. So if I want to do it straight, when I differentiate 1, I'll get 0. And when I differentiate negative x to the power 3, I'm going to have negative 3x squared. So that's what I'm going to get. So for this one, I don't even need to simplify it, and then I'll just plug in my 1 from here. So I'm going to have 2 times 1 plus 4 times e to the power 1 minus 1 cube times minus 3 times 1 squared. So let me come down here. I'm going to have f prime of 1 to be equal to 2 plus 4. This one will be e to the power 0. So e to the power 0, this is to the power 3. Then when I multiply this one will be times minus 3. So I'm going to have 2 plus 4. E to the power 0 is 1 times minus 3. So 2 plus 4 minus 3. This will be 2 minus 12. And this should give us minus 10. I hope I did it right. X squared. Okay, I did it right. Okay, yes, I did it right. So we did it right. So this is negative 10. So now I'll come here and write y minus 5 is equal to minus 10 x minus 1. Simple. So that will be the equation of the tangent line, right? So that's what you are going to get from differentiating the function and working with the function there. Now let's look at the 3. So this question here, we have the table here, so we are going to use the table to do what's here. Now we've talked about this. We've talked about this. So we just do it and then we just do the substitution. So for us to find h prime of 0, first we need h prime of x. So since we have f of h of x to be equal to f gen of x, what is h prime of x? This is f prime, then I maintain gen of x times, then now I differentiate gen of x. So now this is now h prime of x. So now I can substitute the 0 in. So I'm going to have h prime of 0 to be equal to f prime of gen of 0 times gen prime of 0. So now what is gen of 0? This is gen and this is 0. So where they are going to intercept. So gen of 0 is 1. 0 is here, gen is here. So gen of 0 is 1. So here will be f prime of 1 because gen of 0 here is 1, right? Times what is gen prime of 0? This is gen prime, this is 0. So we are going to have negative 3. So this will be times negative 3. And this one will be equal to what is f prime of 1? This is f prime, this is 1. When I come here, I'll have negative 3. So negative 3 times negative 3, and this is going to give us positive 9. Is that right? Now let's look at this one too here. For me to look for k prime of 2, I need k prime of x. So I have k of x to be equal to f of x to the power 3. So k prime of x, applying the power rule, we are saying that 3 drops down, maintain the whole function, 3 minus 1, right? Then I'll multiply it by the derivative of what is inside the parentheses, which is going to be f prime of x. So when I simplify this, I have 3 f of x to the power 2 times f prime of x. Now I need k prime of what? 2. So k prime of 2 will be equal to 3 f of 2 squared times f prime of 2. And this is going to give us 3. Now f of 2, let's go to the table. F of 2, this is f. F of 2 here is negative 5, right? Yes. So we are going to have negative 5 squared. Then we need f prime of 2. F prime of 2 is 3. So we are going to have times 3. So 3 times 25 times 3. Then this is going to be 3 times 25 is going to be 75 times 3. So 75 times 3 is going to give us 522. I'm sure, yeah, it's right. So let me just do it here and see. 3, 5, 15 plus 1. 3 times 7 is 21. 21 plus this is 22, which is right. So that is what you are going to get for the function, right? So yeah. So now this is the last one, and this one is like, you want to do some expand out. You want to expand out this function. So what I want you to do is you can just expand and then put your final results in the comment section. So this times this plus this times this, then plus this times this, and this times that. Then you are done with the expansion. You just simplify. So this one too, you have this one here. Just plug in 2, right? And then plug in 1 and find the difference. And then you are there. So see you in the next video.